So, in today's video, I'm going to discuss about the topic called as mass storage system, which comes under input-output system in the Unit 5 OS. So, here is the overview of mass storage system. We are going to see about the disk structure, disk attachment, disk scheduling, disk management, swap space management, RAID structure, and stable storage implementation. These topics are very important in 5th unit. We can expect questions from these topics. What is the purpose of mass storage systems? We have discussed about the primary and secondary storage in the initial classes in operating system. We are going to see about the physical structure of the secondary storage, how a disk will be, where that head starts. So likewise, to explain the performance characteristics of the mass storage devices and to evaluate disk scheduling algorithm, we have studied CPU scheduling. Now we are going to study about the disk scheduling algorithm to discuss operating system services provided for mass storage, including RAID. Overview of mass storage structure. We have magnetic disks provide bulk of secondary storage of modern computers. Drives actually rotates at 60 to 250 times per second, and we have to speak about the transfer rate. It's actually a rate at which data flow between drive and computer. Positioning time is the time to move disk arm to desired cylinder and time for desired sector to rotate under the disk head. And disk can be removable. Drive attached to computer via input-output bus. See, here is the general structure of a secondary storage system. These are all the disk placed in the arm. So here is the read-write head. The vertical line is called the arm here, and the center thing is called as the spindle. And you have n number of disks placed on that spindle. This is a platter, and the dark blue is called as the sector, and the light blue is the track. So let's see how it works. It rotates in the clockwise direction. Hard disk. Platters range from 0.85 inch to 14 inch. Commonly 3.5, 2.5 and 1.8 will be there. It ranges from 30 GB to 3 terabyte per drive. And if you see the performance, it have transfer rate, effective transfer rate will be there, and seek time can be calculated, and average seek time can also be calculated. Average latency is half latency. Latency actually depends on the spindle speed. Hard disk performance. Access latency can be calculated or average access time, which is equal to average seek time plus average latency. For the fastest disk, they have calculated as 5 ms. For slow disk, we have 14.56 milliseconds. And similarly, we can calculate average input-output time. So the example they have given here. The first commercial disk drivers in 1956 they have generated by the IBM. Ramtech computer included the IBM Model 350 disk storage system. It's actually a 7-bit characters, and platter size is 50 cross 24. And access time is equal to less than 1 second. Solid state disk, which is a non-volatile memory, which is used like a hard drive and can be more reliable than HDD, which is more expensive per MB, maybe have shorter lifespan, and it is less capacity, but it is much faster. So these are all the characteristics of solid state, and then magnetic tape, which is the oldest one. And disk structure we have already seen. Disk attachment, we have SCSI itself in a bus, and we have FC, which is a high speed serial architecture. And storage array we have for storing purpose, for temporary storage. And we have storage area network, LAN and WAN, which is a client server architecture. LUN masking we are using here. So network storage, attached storage, which is actually storage made available over network rather than over a local connection. So that's all about mass storage management.